Example, do not integrate. Form the integral to find the volume of the following solid. The base of the solid S is a circular disk with radius r. Parallel cross sections perpendicular to the base are squares. We begin by acknowledging that the volume is generated by the integral from a to b of a of x dx, where a of x is the area. Our base is a disk, and we'll let it have radius r. The cross-sectional regions are squares. We'll sketch a few of those in, and the area of a square is equal to the length of the side squared. We need to determine the length of the side of a square. Let's draw a circle, that's the base, on a coordinate axis. The distance from the center to the circle is the radius r. Now we inscribe a square within the circle, label the distance from the center to the side of the square x. For the right triangle with radius r and side x, we label the opposite side y, and by symmetry the length below is also y. Now we have the length of a side, and that's 2 y's. So a of x is equal to 2y squared. We need this in terms of x, so we express y in terms of x as follows. We are working with a right triangle. That is x squared plus y squared equals r squared. Let's solve for y. Then y would be the square root of r squared minus x squared. And so for the area formula, where a of x equals 2y quantity squared, let's square the 2y and also replace the y with the square root of r squared minus x squared. 2 squared gives us 4, and we have the square root of r squared minus x squared squared. That takes us to 4 times the quantity r squared minus x squared. Now we have a formula for the area. For the volume, we integrate a to b of the formula for the area a of x dx. So our volume becomes the integral from negative r to r, 4 times the quantity r squared minus x squared dx. We recognize that this area function is even. Using the properties for integrating an even function, we can simplify the volume a little bit, as v equals twice the integral from 0 to r of 4 times the quantity r squared minus x squared dx. And here is a 3-dimensional sketch.